Okay, greetings. I'm Jeremy Simon with 3D Universe, and welcome to episode 20 of 3D Universe Untethered. In this bi-weekly live stream series, we get to hear from people across all sorts of different industries about the great things that they're doing with digital fabrication. As always, you can visit 3duniverseuntethered.com to see all of our upcoming episodes and access recordings of any of our previous episodes. You can also get 3D Universe Untethered as a podcast through any of the major podcast platforms. And if you're watching us on Facebook Live today, please join us by commenting there. We will try to keep an eye on those comments so that we can bring you into the discussion and address any questions that you have either during or at the end of our discussion here. So as I mentioned, we get to hear from people across all kinds of different industries in this series, and we get to hear some great stories, but the benefits of digital fabrication really go beyond industry. And sometimes these technologies can enable motivated groups of individuals to come up with solutions when larger organizations either cannot or will not do so. Now, I think we can all agree that 2020 was quite the year, and among the many impacts of the COVID pandemic was the disruption of supply chains. And one of the biggest places that we saw that in the early stages of the pandemic was PPE, personal protective equipment, masks, and things like that. There were tremendous shortages, and our medical personnel just could not get the protective equipment that they needed. So to address this challenge, a group of volunteers came together in March of 2020 to collaboratively develop a number of open source mask designs that could be produced using affordable digital fabrication technologies, things like 3D printing and laser cutting and desktop vacuum forming. This group eventually became known as the BE Mask Team. The BE stands for Buffalo and Enable, representing the two primary communities that joined forces for this initiative. And if you head over to our website after this at bemask.org, which is still a work in progress, but you will find it there, and you'll find lots of additional information there about our team and our work. And as I said, it's a work in progress, so bear with us as we're still fixing some issues, but you can find a lot more detail at bemask.org. And we have some of the members of that team here with us today. So at this point, I'd like to invite my colleagues here to join me on screen so that we can learn more about this project. So if folks want to turn on your video here and join me, we'll get started. Okay, and I think we'll start with a round of introductions if we could. I've already introduced myself, and I think most of our watchers know me, but in terms of this project that we're talking about, I got involved very early on, again, back in March of 2020, and I've been active part of this team from that time all the way up through now, and we continue to have meetings, and it's just been a great pleasure to be able to work with this talented group of folks. So let me ask John Schult, please introduce yourself next. Maybe let us know any kind of a little bit of your background, any organizational affiliations, and just a bit about what your involvement in this project was.
I'm John Schult. I am co-founder of Enable. Before that, I was a professor at RIT. Before that, I was an entrepreneur developing an internet company. Before that, I was a biological psychologist. Whether any of that background is relevant is an interesting question. But as co-founder of Enable, I was interested in using digital technology to develop solutions to problems that industry was failing to meet. And I was recruited into this fledgling effort by Jim Whitlock, who's also on this call.
Excellent. So let's go to you next, Jim.
Sure, I'm Jim Whitlock. I've been a little over 50 years in computing. My background is hardware development and operating system development, which operations I shut down at the University at Buffalo. I've been there for 47 years. And I had been promoting 3D printing on campus, a couple of pockets, donating equipment, sometimes funds, sometimes just time and a lot of energy. As a advanced manufacturing, exposure to advanced manufacturing. And then all of a sudden, the pandemic struck, and gosh golly, we all of the groups on campus and beyond got drawn into this effort of I don't know who to call it. Is it of Jeremy? It's of all of ours. This collaborative effort, yes.
Absolutely.
Yeah. And I have to say, it's one of the most extraordinary and broad based collaborative efforts that I've ever been a part of. And it's just been a delightful experience.
Yeah, it's really been something quite special.
Mm-hmm.
Let's go to Ben next.
Let's see. So I've been working with the Enable community the last few years on a media coordination project. And before that, I worked for a number of NGOs internationally in different places on programs development and different things. During the beginning of the pandemic, I got involved in really sort of looking at the media coordination side of this project. So in the beginning, it was a lot of note taking, and that's gradually developed into a couple different websites. And again, there's the products that we, physical manifestations of this collaboration, and then there's the footprints behind every design iteration, and it's been really interesting. It's been an interesting challenge to try to keep up with it, and I think this is really a sort of an exciting moment to be able to map it out, and the team really has covered a lot of ground, so I'm excited to be here.
Great, glad to have you with us. And Kelly Cheadle.
Hi, I am Kelly Cheadle. I am the artistic director of Origami. So I am an internationally renowned balloon artist by day, at least when there's not a pandemic, because basically in early February in 2020, our calendar emptied along with the calendars of many other artists and entertainers. And so we kind of caught wind that something was going on that was pretty big. And as soon as that happened, the first thing I wanted to do was try and fix it. I'm not going to fix all the things. So I started working on mask development and, more traditional sewn masks and other things you could make with stuff that you had around you, figuring that people can't go out and do things. And I think lots of other crafters and makers were kind of driven by that call to arms of, well, you can just wear a bandana, and we knew that wasn't good enough. So John and I have worked together over the years randomly on different innovative things. And I think that's how I got drawn into the project, was seeing several of his early iterations where he was also trying to find things around the house that you could use and adapt. And it caught my interest. So I kind of joined the crew in the summer by the time.
Very nice.
Yeah.
Excellent. And we have Mara Huber with us by phone. Mara, I don't know if you caught the intro, but if you could maybe introduce yourself and give us a little bit of your background, please.
Sure. Hello, everyone. My name's Mara Huber, and I serve as Associate Dean for Undergraduate Research and Experiential Learning, and I direct our Experiential Learning Network. And so my job at the university is really to help facilitate and support efforts that result in engagement opportunities for our students. And our students really benefit when faculty and staff are engaged in relevant and compelling opportunities with the community. So I think this is just an exciting example of being responsive and being dynamic. And I'm particularly interested to see how this will result in meaningful project opportunities and engagement for our students.
Wonderful. So glad you could be with us, Mara. Thank you. So we are going to do a little bit of show and tell here. I want to be able to show our audience the designs that we came up with. But before I get into that, I do want to just give a couple of other quick acknowledgements. There have been so many people that have been part of this initiative from the beginning. I can't possibly name them all. So I want to apologize right up front for those people that I'm not going to call out by name, because there have just been so many. But I do want to mention at least a few of the people that have helped us along the way. Dr. Albert Titus, who is the chair of the biomedical engineering department at University at Buffalo, was the one who really got the meetings going and started to coordinate those initial meetings, and has been part of this from day one, continues to help us out, helped with a lot of the testing, built mechanisms for testing our filtration materials and things like that we'll talk about. Dr. Praveen Arani with the School of Dentistry at University at Buffalo, also a tremendous help to our team, especially when we started getting into working with some of these transparent mask designs that we'll talk about. Also Philip Sales, who was on his team as well, tremendous help during that prototyping stage, testing, doing documentation, tutorials, so many different things. Mohammed Faisal Balam, a gentleman from Kuwait who actually found his way to us and for several months was working with us, helped with CAD design, brought some great ideas to the table, and actually found great success using these designs that we were coming up with in Kuwait. The medical professionals there were desperate for solutions and welcomed what we were coming up with. as well as some industry partners that were of tremendous help to us. Peter Cifolletto, who is an owner of PVS Process Equipment, helped us a great deal. He actually purchased a number of 3D printers just to help with the prototyping and sort of scaling up production as we were working on 3D printed masks, helped with a lot of the CAD design work. Bob Bechtold with Harbeck in New York was very generous in donating the entire cost of doing a mold for injection molding one of these designs, but also contributing an enormous amount of his own time in joining us for these meetings and helping with the designs and the iteration work. Dr. Peter Elkin, another professor with University at Buffalo Department of Biomedical Informatics, professor of internal medicine. He's also associated with Jacobs School of Medicine and Biomedical Sciences. Anyway, Dr. Peter Elkin was a tremendous help in advising us, giving us advice throughout this process, helping us with testing, especially when it came to the sort of the seal, how it fits on the face, and comfort of wearing these masks in an actual healthcare environment, and that sort of thing. Skip Metz, one of our long-term Enable volunteers, who was helping us with prototyping and CAD designs and helped us come up with all kinds of neat ideas to explore along the way. Aaron Gorsline, one of our interns through the University at Buffalo, who helped us. He originally joined us just to help with documentation, but he ended up getting involved in design work and prototyping and all kinds of helpful work with us. Jack Singh, another member of the University at Buffalo team. He's a computational anatomist who helped us with analyzing face geometries and helping to come up with sort of average sizing for small, medium, large, and that sort of thing. Will Byron, who brought a lot of business background to our discussions. And as I said, there are so many more that I could name, and please accept my apologies for not going on because there are just too many, but I do want to thank everyone who helped us with all of this work that's happened over the last, I guess, about a year and a half now. It's really been a special team and project to be part of. So let's do some show and tell. I want to start with the 3D printed mask because that was kind of just chronologically where our focus started. And as we kind of go through this, we're going to talk about the context of this and how things started to change. But as most of you will recall, back in the beginning, the challenge was just a shortage. You could not get masks. And so that was our initial focus. We've got these 3D printers, a lot of us, especially with the Enable community, we got a lot of volunteers with 3D printers. What can we do with those? And we started actually looking at mask designs. And through a lot of exploration and iterations and testing, we started moving in this direction. And this is what I'm holding up on screen is a 3D printed mask that is based off of what you might have heard of. It's called the Montana mask. This is a different version, but it comes from the Montana mask design. We made some changes that we felt were improvements by adding a sort of a reinforcement frame for the filter material in the front there, opening up the area a little bit more for the filter, changed the shape a little bit to make it more comfortable. But most importantly, we started printing it in flexible materials, including this, which is a very soft material. It has a sort of a foaming agent in it so that when you print it, it actually produces very soft, very flexible prints. And so we came up with definitely an improved version of this design, but what we quickly started to realize was that breathability was a challenge. When you're wearing this, especially for any period of time, trying to breathe through a filter with this much surface area, especially when you double up the filter material, which we started to do just to make sure we were giving a really good, safe level of filtration. What we were using here is a filtration material. This is something that we cut out of industrial air conditioning filters, and this is rated as a MERV 15 filter material so that we knew it was effective. We knew that it was essentially the equivalent of an N95 level of filtration. But we were using 2 layers of this, and with that amount of surface area, it became difficult to breathe. And so we then started looking at what could we do. We looked at making it a little bit larger. You can see how we kind of made that breathing area a little bit larger to try to give us more surface area. But the larger you go, it starts to sort of interfere, with your line of sight. It starts to get out of hand. So long story short, we eventually found our way to this, which is a corrugated filter cartridge. This is a 3D printed cartridge where the same filter material can go inside, where it's being bent back and forth again and again, so that in the same relative kind of surface area or the same relative size opening, you get much more surface area of the filter. And this really helped with the breathability. So this was the latest version of a 3D printable, what we call the BE mask. And this is a design that we released as open source. Files are available for download. Anybody with a 3D printer can make one of these for themselves. They can source the materials, put them together, and we will make all of those files and instructions available through our website. After, this went on for some time. We're months into the process now, right, guys? So now the landscape is shifting under our feet. The shortages aren't quite as critical as they were before, but at the same time, we're starting to realize that there are other problems associated with wearing masks all the time. And this is, I think, around when we started having talks about the benefits of maybe a see-through or transparent mask. And I don't remember, was that you, John, or you, Ben? I think it was one of the two of you that started bringing that up for discussion. Can one of you talk to us about kind of where that came from and why we started thinking about the importance of transparency?
I can do it. I think in our group, I was aware of work that was being done by people, including Kelly, in which a clear window was being put into a cloth mask. Kelly may be reaching for one now. But I was thinking about politicians and public figures. This was, of course, during the heyday of the Trump administration and the COVID crisis. And I was looking for a way of having these things be less of a burden on social interaction. And so I got very interested in a clear mask. Also, because I had already spent several months playing around with clear plastic sheet protectors and other home items that could be potentially turned into face masks or face shields. So at that point, I started talking about this with the group. And while I was doing all sorts of bizarre things with sheets of plastic, Bob Bechtold from Harbeck Plastics, who had been sitting in with us, actually, I think if I can pick up the story, took it upon himself to say, basically, you guys have been talking about this for a really long time. I'm going to see if I can't remodel something that can be injection molded. And so he came up with a clear injection molded mask, which was really a very helpful step forward for us. And Jeremy, you can now describe the features of that mask.
Well, so I'm holding it up on screen, and what this is I'll call it a translucent. It's fairly transparent, but of course nothing is perfectly clear. So there's translucency. And this one has been, to be fair, lying around for a while, so it needs a new application of the anti-fogging treatment, which helps a lot. But this is a transparent mask that was injection molded, and then it has a 3D printed cartridge that is mounted on the bottom. So this would sit when you put the mask on, that sits under your chin. And that leaves your face exposed so that you can see the person's mouth, you can see an expression, and yet you're still getting that good filtration, breathing out through that cartridge that's sitting under your chin. So this was an interesting sort of meeting of two worlds, where we were using 3D printing for the cartridges for the filtration, using injection molding for the mask body, using some traditional assembly when it comes to the elastic straps that go on there. I know there were plans to look to injection molding for the filter cartridges as well. This was, again, an example of how 3D printing can be used as you start to scale up production before you're ready for the injection molding. But yeah, this is a great example of where we're starting, we're getting far enough into this process. We're starting to think about, okay, we have some designs. We can start to release these open source designs. Not everybody has a 3D printer. Everybody, a lot of people out there need these masks. Should we be exploring other production methods? And so along came Bob Bechtold, and we had the benefit of being able to explore injection molding, which we would not have been able to afford had it not been for his generous offer to contribute that. So we do have this as a second design that was introduced, the Harbeck mask, and this is something that we have this mold ready, we can produce these, and it's a great solution. I think it's well suited for the more industrial environments. It's a thicker mask, it's very robust. So I think it's well suited for environments that need something, creates a great sealer on the face because of this soft kind of silicone material. And so that's a great option for somebody that maybe needs a more industrial level solution. Now, this is all complicated. Again, talking about changing landscape. As luck may have it, as of the time of this session, as of yesterday, the FDA has now revoked their emergency use authorization when it comes to non-certified filtration for masks. So that's going to change who could use this or benefit from this. It's kind of out of the picture for healthcare professionals at this point, unless we pursue full certifications. But that's That's the way it goes. Things are constantly changing here. So that was the second design that we came up with, an injection molded clear mask. But then we continued to explore other ways of achieving clear masks, and our attention turned to, among other things, vacuum forming. And at this point, I want to turn it over to Kelly to talk to us. So Kelly joined us in the summer, about the time we were starting to go down this path. John was playing with more traditional techniques, but I think, Kelly, you have some of the samples of that there. So talk to us about maybe some of the more traditional stuff first. Maybe we'll start there with like things you were doing with materials around the house, and then we can talk about how we got, from there to vacuum forming.
Yeah, so it's been a wild ride. I'm sure the rest of the group can attest to the number of ideas that were generated by the team here in Rochester. So John was mentioning, or you were mentioning earlier, about the clear panel mask that I had designed. So going back to traditional handicraft and things that people had access to, lots of people have sewing machines. Fabric is really accessible for folks. I mean, you've got sheets, you've got material around the house that you can use. And there were some folks in California, some ladies that were testing out the filtration abilities of different materials around the house because of that difficulty in the supply chain. So there were a few clear panel masks that were starting to be produced, but a lot of them were, it's interesting to see how someone's background influences what they create. So a lot of them were being created by quilters who are used to piecing together lots of individual pieces. So a single mask could take you several hours to produce because you're cutting out like 5 and 6 pieces. And I was like, nah, we're doing this in 3. Like, so this was the Happy Turtle design. So you can see. Now, John's complaint about this was that it was a little bit dorky, but it got the job done. So that was one of the early iterations. One of the other things we were working, or that I was working on before I joined you guys, was, again, having difficulty finding completed masks, or the N95 masks, but the regular surgical masks were a lot easier to kind of get your hands on, a lot easier. But the fit on these, these big air gaps and the seal around the face was difficult. So John was helping me with this little thing, was a recurve. And this is just a little piece of wire that would fit over a traditional surgical mask. And then you could adjust it with just by stretching the wire. And suddenly you have a much better fit with, a certified material. So all of these various things that we were playing with kind of, and this was one of the earlier ones out of transparency sheets that John was working on. But then we started playing with the vacuum former. So we had the Make You in the office.
I got to say, there was a moment when I was showing up with one Starbucks plastic cup after another on my face.
Yes.
And of course, those plastic cups are all vacuum formed. And Kelly said, instead of figuring out how to retrofit a Starbucks clear plastic cup, we really ought to get a vacuum form.
So yes, so
vacuum
we did.
So that's how we got that. Okay.
Well, the plastic cup design was pretty cool. And for those of you who haven't gotten a chance to play with one yet, you create a base form, heat up a piece of plastic, and it's sucked over and forms over the form that you have on the sheet. So sometimes building those original forms when we were first starting, we wanted to kind of quickly go through different shapes. And one of the shapes that I wanted to kind of play with was this sort of pear shape. And so we literally, this is vacuum formed from an actual pear that we just sliced the bottom off of. Because
Beautiful.
We're about right,
I love it, yeah.
But it worked, and it was a quick way to kind of iterate, this is the direction we kind of want to go in. And so from there, and Praveen's team also did a lot of work with the vacuum former. So we ended up doing a lot of prototyping with the regular filament 3D printers. This was one of the later designs.
So that's a 3D printed mold that was then used on the vacuum former to make a test, a prototype. Yep.
Yes, and you can see how the little striations that are in the filament printed, this one wasn't sanded. We tried sanding, and that worked pretty well. But you can see how that carries over. Hey, Lon, look, Wonder Wheel. This was another another various iteration. But so it created lots of opportunities to rapidly test different designs. And as we refined, the shapes that we got and kind of got closer to our final pieces, being able to move up to an SLA printer for a mold, you got this nice smooth finish that barely required any modification. And we were able to go from this to a very smooth vacuum formed print, or whatever you want to call it, to go, create the mask shape. And this is actually one of the masks that was created by Praveen's team. And as we were going along, there were so many different iterations of these masks. And, as we got into production of, more than one mask, the things that were cute, quickly became, an extra step. So it was a lot of editing down of these sort of brilliant and fabulous ideas into like the best process is no process, but if it just works. So this was able to be vacuum formed and then cut out. And the filter, the sort of lower area filter is kind of what stayed through as far as many of the designs as they went. And this was just the MERV material. And on this design, you can see there's just holes punched into the bottom. And, later we figured out, well, we can just cut out the whole bottom section. Why are we blocking part of it with the plastic? So where should I go next, Liz? Oh, actually,
go to the final design, which eliminated the flat panel underneath.
Yeah, so one of the challenges we had this mold and we're like, all right, we're ready to go. Let's produce a whole bunch of these, and then realize that this lower area that we would cut away, if you're doing an industrial stamping process, you want that cut layer to be on the same plane. So this little mountain here that you had to cut over would require a really complicated setup in order to cut. So how are we going to get this shape into a flat surface? So one of the really, I don't know what the heck made us think of it, but we actually took one of the existing molds. It was probably just because we were like messing around with it. And we figured out that if you, so this is actually the one that kind of got it going. So this was the regular 3D printed vacuum formed mold, but we stretched it out. Pardon me as I get plaster everywhere. We found that if we wanted this surface to be at the level of this, if we just pulled the mold and then poured plaster into it, we could get a flattened version of the shape. And because of the flexibility of the PETG, when you pulled these sides back together, the shape returned. So that was a huge step forward, and which brings us to the final version that we have. So this is you can see the cut is all on the same plane. And then in order for the mask to fit over your face, there's a little slider. So the two little legs go into the slider, and then you can adjust the shape of the mask just by sliding the slider up and down. So that the higher up, the narrower it goes, further down, the wider it goes. And as far as the filtration material goes, this actually works in our favor, I guess, that we did jump to a surgical mask that has been approved. This particular surgical mask is a little different from the square shape that you've seen. It's sort of, I think they call it a fish-shaped mask, where it's sort of sculptural. So this is how it's normally worn. But I think part of this was also inspired by, you go somewhere and people would always lower their mask and wear it on their chin. But we decided to carry that over to the mask. So once it's sized, you just bend the bottom legs to the side, and the mask is attached to the bottom of the clear panel. So you can see on the inside what happens. It kind of sits, but these little legs also extend the mask out to create a larger area to breathe through. Like Jeremy was pointing out earlier, how difficult the tiny area to breathe through was. So now we're using the same straps that were from the original mask, and you can see what I'm saying, and it's not too bad.
Very nice. And now this is a good opportunity to touch on the fact that as we're doing this, we're constantly kind of going back and forth, looking at, things that can be produced sort of at home, or, sort of a do-it-yourself type approach versus sort of scaling up production and producing larger quantities. So now we've come up with a mask that, can be mass produced, that we can do vacuum forming at scale. We can produce a whole lot of these. We can source the materials, but then sticking with the theme of a transparent mask, but kind of turning our attention back to what can we do with available materials, led to even further exploration. So there was another one that we're calling the B-cycle mask, using recycled materials. Do you have one of those there, Kelly?
I do. So this is the B-cycle. I'm using, so this normally would have non-frosted tape, but this kind of helps to show you some of the materials that are being used in the mask. Mm-hmm. And this is, you may recognize the curve of this. This is the side of a 2-liter bottle. So that, because we noticed that there were lots of similarities between the curve of the pre-existing bottle with the curve of the mask that we developed. So it actually has a very similar format where the mask shell is similar to the vacuum formed version. Although in this case, because the tendency of the soda bottle is to curl in, this little positioning of the legs is slightly different than the tulip shape of the other mask. And so just with a series, we're working on the instructions, but with a series of cuts and folds, it's not as comfortable necessarily as the other mask, but if you don't have access to a 3D printer, there's a little bit of gaps here. This is the area that we're most kind of still working on finding solutions for. But you can see, you've got a pretty good view of my face. Yeah. There's some little gaps over here. So it's in development. I think we could get there, and I would love to see other people kind of give it a shot and see how they can move it forward.
Well, and this is one of those examples where we've just had so many people involved throughout this process. It gets to the point where it's hard to remember kind of what started with whom. I think Skip Metz was maybe one of the first ones that started experimenting with this recycling bottle concept. So I'm sure there's going to be other cases here where I don't give proper credit to the right individuals. There's just been so much participation in this along the way. But it's worth mentioning also, just kind of going back to the context of this a little bit more, now that we've sort of talked about some of the different masks and the designs that have come up along the way. There was a lot going on along the way here, and it really was the community here, as the university at Buffalo and folks throughout the faculty, staff, as well as students, that really kind of got things going. They had some existing 3D printing groups there, and that was, I guess, what really got the ball rolling. The Enable volunteer community, being represented here by John and myself and Ben and Skip Metz and others who were involved along the way. We got involved, and I think that was a really interesting kind of a marriage, if you will, because here's this global volunteer community in Enable. For those of you who may not be familiar with it, this is a global community that uses mostly 3D printers, but also other kinds of technologies to produce assistive technologies. Mostly we're known for prosthetic hands and arms, but we're also doing other kinds of assistive technologies, and we give them all away for free to people that need them in underserved communities around the world. And it's just a really cool group to be a part of. But then along comes this pandemic. Obviously, we kind of back off on, the amount of, hands we're making and certainly delivering in person to people. But here comes this need all of a sudden where there's these critical shortages. And at the same time, we realize we have this community of people, literally thousands of people with 3D printers. If we could come up with the right designs, we have this network we could mobilize to really make an impact. So, it was interesting to see how these groups came together. And to me, what excites me about this whole thing more than the designs, I mean, the designs are great. And I think it's great that we're able to share these as open source. That was the whole thing I signed on for in the beginning. I wanted to make something that we could share freely and let people kind of iterate on and build off of. But at the same time, being able to just be a part of this process, this group of such amazingly talented people. I mean, I mentioned some of them, but we've got, doctors and engineers and material scientists and business people and just you name it. We've got all these incredible backgrounds and skill sets that came together, everyone volunteering their time, nobody looking to get anything for themselves out of this. We're all just looking to try to, fill a need, just try to address this challenge that's there. And that to me was the part that was so exciting to, we got ourselves into a situation here that, nobody saw this coming. The big companies were not ready for it. They got blindsided. And we got into some really, troublesome situations, especially with the frontline healthcare workers. And to see that a group of like-minded individuals could just come together and kind of work together to solve that, or at least come up with possible solutions for that. That's what's really exciting to me, knowing that this is something that, look, I hope we never see this again, but at the same time, chances are we will. Chances are COVID is not our last pandemic. And it's just good to know that next time something like this hits, we have a mechanism, we can mobilize and we can make things happen in pretty short order. That to me is pretty exciting. So I'd like to talk a little bit. Sorry, go ahead.
I was just going to say, it's probably worth noting that Enable, our group that pioneered the use of 3D printed prosthetics, was among the first of these maker for good communities. During the COVID crisis, it wasn't, of course, just us. It was the entire global maker community, which has gotten even bigger year after year after year, which has produced millions, literally millions of face masks and face shields and new approaches to these problems around the world.
Yeah, and we've had some Enable chapters that have made literally thousands, tens of thousands of these face shields, and that's a really important element of this. It's every bit as important as a mask in many situations.
Yeah, hundreds of thousands in Brazil.
Hundreds of thousands, yeah.
And maybe that's, I was going to say, that's something too about the transparency. I think even well before we were doing transparent mask designs, face shields were something that were accepted more than masks at hospitals and even for the general public. And there were a couple designs. One was from Prusa, the 3D printer company, that were being shared open source, and some of the Enable chapters that in the past had just been doing 3D printed prosthetic hands shifted really quickly and organically on their own to supplying some of these materials for the folks that needed them, the frontline workers. And we had cases in Lithuania where a chapter led by one person basically coordinated, distributed the face shields for the whole country. And in Brazil, it was a huge effort. So we had a lot of, what we were working on, we knew that there were also all these other people working in parallel around the world, which, I think was a big motivating part for me, and I think a lot of us.
Yeah, I'd agree. I think seeing how the whole community responded, as you guys said, not just Enable, but everybody with a 3D printer. And a lot of people, I can say this from experience because I operate a company that sells 3D printers. A lot of people started buying printers just so they could help with this. That was just unexpected. That was really exciting to see that lots of people were, they're home from work all of a sudden and they got maybe a little bit of time on their hands and they want to do something to help. It was really exciting to see how many people jumped in to help make things for their local community and just do whatever they could.
The thing
so that
was
go ahead, Kelly.
The thing that was really interesting to me was to see, the advent of this, or not, I mean, the open source sharing of ideas and the open sharing of concepts, where it's like, I think one of my favorite movies or scenes in a movie is the scene in Apollo 13 where like the filters are running out in the main module, but they can use the filters from the other part, and one's square and one's round, and they can only use the materials that are on board in order to get the square peg to fit the round hole. And I remember watching that and going, I want to do that. And then suddenly we were kind of faced with that, where like we had to use what we had available. So anybody that came up with an innovation and shared it would like inspire like 15 different iterations across the country, across the world, that were then brought together. So this web of development and the distributed mindset, and then the collective bringing things in together. I love watching it.
Yeah, absolutely. There was a lot of collaboration happening, but it takes more than just collaboration. It takes more than just creative people and willingness. So it's worth mentioning a couple of the other things. There are a lot of elements that came together to kind of allow what unfolded. One of those elements, eventually money gets involved. The things that we're doing here take money. You got to buy supplies in order to even do the prototyping, in order to be able to explore these different possibilities. It was actually Jim Whitlock, one of our participants today, who helped us first to get that going. He himself funded several initial orders so that he could have masks to donate and sort of start to get them out there. And at the same time, that helped to kind of accelerate and fuel the work that we were doing. And a little bit further down the road, we had another. We recently had an order that was closed for NTID out in New York for 1,000 of these clear masks for their student population of deaf and hard of hearing, where it's of course of greater importance to be able to see one's face and expressions and the rest of the communication that's happening under that mask. And so these sort of initial sort of commitments and offerings of funding and support were also extremely helpful of keeping things going, and really equally importantly, keeping us on focus. Because you can go off in a lot of different directions. Creative people love to experiment and love to go down every possible different path. But once you get somebody that wants to actually put money on the table and say, I would like to get 100 of those as quickly as possible, that helps to focus you. It helps to get things moving along, and it certainly did that for us. So I want to thank Jim, and I want to thank NTID for their order as well, which is in the works now. So talking a little bit more about the context here, I mentioned some of our industrial partners that came in and got involved here too. So this was, started by mostly people in the academic community, faculty, staff, and students, and 3D printing groups that were out there at University of Buffalo. But the Enable volunteer community got involved, but then other partners started to get involved too, including a couple of industrial partners that I mentioned. These are people not associated with the university and not associated necessarily with the Enable at the time, but they just heard about something going on that they felt they could help with and jumped in to see what they could do. So I mentioned Pete Cifolletto from PVS, who did a tremendous amount of work with us on CAD modeling and exploring possible designs with sort of cartridge-based filters that he was looking at, these circular replaceable cartridge filters that he was trying to source in bulk so that we could make a 3D printed mask that you could sort of plug these sort of higher end certified filter cartridges into. And then I mentioned Bob Bechtold at Harbeck bringing in the injection molding capabilities. Without those partners, things would have gone in very different directions, because we would not have had injection molding as an opportunity. We wouldn't have had some of the 3D printing and CAD experience and assistance that we had along the way. So now go ahead, Kelly.
I was going to say one of the challenges, I think, it's great to innovate, but one of the bigger challenges we had, especially with some of the communities, just depending upon like how intensely they were, it's one thing to, go to the grocery store when you have to. It's another thing to be, in a school where there's lots of people around and you need to be there. So testing the designs that we came up with, having designs that were evaluated for, how well they worked was really important. So I just wanted to make sure we circled back around to that.
Absolutely. Absolutely. And yeah, I want to talk a little bit about that as we kind of talk more about the landscape and the context of all this. A lot of discussion started to unfold around potential liability, risks associated with offering mask solutions or mask designs. Are we giving something to people that is helping them? It's going to make them safer and not cause harm. How do we know that? Are we going to get in trouble? But I think more importantly, knowing that we're not going to do harm. I think that was our main concern. We wanted to truly help people and not harm them. So, there was a lot of discussion around liability, and this goes back to that discussion of changing landscape, because part of that landscape that was changing was what was considered acceptable. I mean, when things started to get really bad, and healthcare providers could not get the masks that they needed to protect themselves, in this country, in the US, the FDA kind of stepped forward and said, we're gonna change the rules, and we're gonna say, look, use what you can get, certified or not. And so they put together an emergency use authorization allowing the use of non-certified filtration media and masks and things like that, which, as it so happens, just expired yesterday. But throughout that whole period, over more than a year, we're in this environment where the normal rules aren't necessarily, what's in play. And so, but that also opened up some uncertainty. What does that mean? What is okay? And how do you, knowing that people are being given the freedom to use non-certified masks, if that's all they can get, how do you make sure that you are giving them something that is, as we like to say in our group, better than a bandana at the very least, something that's not going to put them at risk? So let me just open, I don't want to call on somebody in particular here. Who would like to talk to us about this whole topic of liability? Because there's a lot to unpack here. Some of the things that we explored in terms of risk and liability, and some of the thoughts that went along with that. Who'd like to get us started on this? Okay, we'll call on somebody. John.
Nobody wants to get in trouble.
So one of the challenges about all of this is, of course, that we're all learning, including the medical profession, learning about what were the actual risks and actual liabilities as things proceeded. The sanitation data, you remember all of the washing of food and washing of hands that we did in the early days?
Yeah.
That turned out not to be the critical issue. Over time, that changed. It also became clear that there was such a variety of practices going on, including people refusing to wear masks, people using bandanas, etc., that it became commonsensical that a bandana was better than nothing, and that we might be able to do something better than a bandana, and that the approval process, which is under normal circumstances, the way risks, liabilities, and authorizations are handled by an official bureaucracy. The official bureaucracy basically said, okay, we're going to broaden these guidelines with these emergency use authorizations. And they opened a lane in which this kind of innovation and improvisation could happen. At the same time, it also became clear that institutions went from, we're only going to do things that are authorized, to, oh my God, we've got to solve this problem. And Buffalo and many other universities said, we got a bunch of scientists here. It's time to put them to use to solve this big problem. Over time, I think the institutions said, we have to be careful here because we are multi-million, multi-billion-dollar institutions. And if there is a risk, it could come down very hard on us. Interestingly, at around the same time, it also became clear that a nonprofit, non-organizational model could do things a little bit more freely and with lower risk than the big institutions did. And so there was this interesting transition in our own group between being a group convened by the University of Buffalo to being a group of volunteers, including faculty and staff from the University of Buffalo, but they, by working as volunteers within the Enable non-organizational model, they were able to make great contributions. They were able to bring the brain trust and the facilities of the university to bear. And yet, because we are all mere mortals and we're not representing any formal organization, we were able to limit the liability by being obviously well-meaning souls, being diligent, who you could not sue for $1 billion. And I frankly think that that also creates a big lane of opportunity for innovation and problem solving, which needs to be kept open going forward, even as the FDA and others begin to say, okay, we're sort of returning to business as usual. Let's reimpose some of the guardrails that we have traditionally used to regulate development of health-related solutions. So we're entering into this after times era where we're now beginning to reimpose regulations, but we're doing it, I think, with a recognition that safety nets and innovators and the maker community can play a really important role in dealing with things that big institutions with well-established practices cannot work on.
Indeed.
You know, I wonder if this is maybe a moment to also recognize that at the time, the FDA, the VA, the NHA were following the DIY community for guidance on this. So there was a website that was sort of assembled together that was a sort of a union between some of these sort of governmental agencies that basically was accepting different designs from the community, rating them in different ways, sharing the files, and I think most significantly, modeling, just as you know, our group and others were coming up with different designs for this PPE, they were also sort of ad hoc testing these masks. And again, this is through you know, the government agencies. They were saying, okay, if this is the ASTM standards, if this is what NIOSH is doing, what can we do that's good enough for this in-between process? It's not a bandana and it's not NIOSH certified. We can do something in between. And that inspired our group as well. So there was members like Albert Titus who began following these testing rigs and developing them himself and finding ways that he could show you know, how our mask would respond to being saturated by liquids, how it would respond to different things that NIOSH tests in a very methodical way, but in his own basement. And so we started learning a lot from that about surface area, about the materials that we were using.
As you recall, we actually did earlier on in the process, we did some actual third-party certified lab testing on our filtration as well. And that was useful because then later when Albert built his testing rigs and started to do testing, we were able to compare those results and see that things were aligning and kind of gave us more of an assurance that we were seeing meaningful data from our own testing. So I'd like to talk a little bit about that too. There's just so much to cover here and we won't get to all of it, but being you know, mostly a series about digital fabrication here, I do want to talk a little bit about the technology side of things because it was great that we got into so much of that here. And for me, that was a big part of the fun of being involved in this. So obviously 3D printing was a big part of this at the beginning. And we used, a bunch of us in the team had 3D printers and used those 3D printers for prototyping. And that's always a fun experience. If you haven't had a chance to participate in a sort of a collaborative design prototyping project with 3D printing, it's so much fun because somebody on the team comes up with a design, shares it with the group. And even if you're, you know, halfway across the world, you can 3D print that and you're holding the exact same thing that guy, you know, thousands of miles away is. And it's just a really fascinating experience to have and allows you to iterate really quickly, which we did. I remember in our earlier meetings when we were meeting 3 times a week, we'd have, you know, version iterations between meetings, you know, where we'd have 2 versions that have gone from one meeting to the next. So 3D printing was a big part of the process earlier on, but you know, as anyone who's done a lot with 3D printing knows, it's not great when it comes to real transparency. You know, there are transparent materials, but when you extrude them, you end up with something that's translucent at best. So that's where we started to look at other technologies as well. But while we were on the 3D printing mask, we did use laser cutters quite a bit. I showed the filtration material that we were using and all of those little squares that we were using for that filter material. These were all, you know, these would be cut out on a laser cutter so that it just, you know, didn't have to. You could certainly cut them out with scissors or whatnot, but when we were doing a whole bunch of these at once, it made it a lot easier. So I just made a template and we'd cut out those because they come in these big sheets, the filter material. And so we could just cut out a whole bunch of them at once using the laser cutters. When we got into the clear mask, that's when we started using the vacuum forming more. And so Kelly mentioned this, That's where I realized, hey, we sell a vacuum former. So we offer the Make You Form box, which is, for those of you not familiar with it, it's a desktop vacuum former. So it just plugs into any standard vacuum cleaner, shop vac or something like that. And it's a very affordable vacuum former on your desktop. And so they used that for the prototyping, and that allowed us to do everything we needed right up until we were ready to scale up, at which point we went to a third party, major vacuum former to have it done at scale. Of course, what else? There's the vacuum forming, the laser cutting, the 3D printing, and then traditional methods. I mean, sometimes it's easier to forget that that's a part of the prototyping, but John was playing around with transparencies and sticky tape and Velcro and who knows what else. Those were important stepping stones along the way, sort of in between the points where you're using the digital fabrication technology to try things out. You're kind of in parallel with that. You're trying out these other things with things that you have on hand.
As far as the traditional materials went, John and I, we made a mess of the studio. So I have a little makerspace set up at our art studio, and I still need to clean up some of the experiments. But one of the things that we played with when we were working with the plastic bottles was, what happens when you use heat to modify the existing blow molded soda bottles. And we found that when you heat something up, it kind of wants to return back to the way it was. So we'd get these like fascinating little rolled edges on the edge of the soda bottle, and we're playing with that. It's a little too strong, but there were so many little inspired discoveries along the way that may not have made it into the final piece, but from a materials and process standpoint, were just fun. Like there was talking about the comfort and fit around the face, like that's where this sort of rolled edge came from on the plastic bottle. We also experimented with gaskets. This is I think this is a CPAP mask, I'm not sure, or maybe CPR mask, which has the inflated padding over here, which I deal with balloons all day long. So I was pushing for an inflated gasket for a long time, but so we ended up with some rolled plastic at one point, which was super comfortable, but a super pain to manufacture.
We tried a lot of stuff for the gaskets. I remember we tried gasket lining material, the sort of the U lining material, various types.
And so what happened with the vacuum form piece, and I don't have the mold for this final design, but we ended up inverting the edge of the mask so that way you didn't have like a sharp edge up against the skin, because again, right. You don't especially some of the early days of COVID, when people were really tying down their masks really hard to make sure they were getting a seal and using their flesh as that gasket, you'd end up with abrasions on people's faces. So we really wanted to make sure that there was a smooth finish up against the skin, so that inverted mold makes a really soft, low pressure, no sharp edge against the face. So it's been a trip.
That it has. So one of the interesting things. Go ahead, John.
I'm sorry. I was just going to point out that the other bit of digital technology that is really crucial to this is the fact that all of these designs can be sent back and forth in real time. The video conferences that we had 3 times a week for month after month after month were a really important bit of digital technology, and supports this collaborative innovation style in which you learn by doing and by interacting with the materials and with your coworkers. I think that's actually that's an important part of the secret sauce of digital technology.
It is, absolutely. It's the combination of those internet technologies with these digital fabrication technologies that really starts to open up these incredible possibilities. As we see, that's what we saw in the Enable community, and that's what we saw again here in this project, and it's wonderful to be part of. Another aspect that I think was unique about this initiative here is we've kind of touched on this, but the different types of production, and seeing how we had to kind of shift our thinking, where in the beginning it was all about prototyping and figuring out how to get a design where we could sort of share that design and people could make it for themselves. But then thinking about, okay, that's fine for the people that have a 3D printer or a vacuum former or whatever the technology may be. But we still have this challenge of people out there, not just in our region, but all over the world, that just couldn't get the protective equipment they need. So we also wanted to challenge ourselves to think of how can we make these masks available and make them in larger quantities so that people could just say, yeah, I need 1,000 of those, or whatever the case might be. And so where we were using, 3D printing and vacuum forming and this, that, and the other thing in the beginning for all of our prototyping, that switched over to injection molding and industrial, excuse me, I have to turn off my Alexa here, and industrial vacuum forming, die cutting to have the actual formed plastic pieces cut, silk screening for the bags that we're packaging them in. You get into all the distribution considerations. How are we going to warehouse these? How are we going to get them shipped out to people? How are we going to, allow people to put in orders or requests for these? So these are all things that we had to start thinking more and more about as we went through this process. Just how do we get these into the hands of people that need them? Which is a whole different set of challenges.
That whole distribution piece, like as far as Enable goes, when you guys are working on the prosthetic pieces, those are generally customized to the wearer. So it's a very intimate, ongoing process. This is more of we just need to make a bunch of these and get them out there. So even as we're looking at production and making them accessible to people, like we've got a little package for the individual one, but if for some reason someone halfway across the world decides that they want, to use these, either, if they have access to vacuum forming, which in some areas of the world, that's one of the easy to use, super cheap methods of manufacture. But like, this is 50 adapters in one little tiny box. So like, even just trying to think about how do we share not only the digital versions of these, but how do we share the physical versions that we were able to mass produce more efficiently with an industrial process versus making one at a time on a little tiny
exactly and those are some of the things we're exploring now. We're going to be helping as we can through that process through 3D Universe. Just as I mentioned, somehow we need to figure out how are we going to distribute these, how do we get them shipped out to people, how do we facilitate orders. Well, we have all that infrastructure in place, so we're going to be able to facilitate that, but we're still kind of figuring out how we want to offer this. Right now you can head over to beclearmask.org. That'll take you to a page where you could get one of these clear masks for yourself if you want to check them out, try one. But as Kelly said, we'd like to also make them available in packs if you want to buy a whole bunch of them at once and sort of put them together yourself. We're going to be offering kits that have the sort of the raw material components where you can buy the materials along with a vacuum former of your own, maybe to put in your own shop or your own maker space, and then get the materials and make these masks for your own team. And so we're still kind of sorting through those options. Just check our site for more information. But if you go to the main site for this team, which I mentioned at the beginning, bemask.org, which is, again, it's still a work in progress, so bear with us as we continue to update it. But that's the site where you're going to find all the details for all these designs that we've talked about, including the source files. Because I want to reiterate something that we talked about in the beginning, which is that all of this is open source. We've come up with, I think, some really useful designs here, all of which they're going to be downloadable from our site. You can download the models, you can download the files, you can download the instructions. If you want to change it and come up with a new version and share that with the public, you're welcome to do that. And we would love nothing more than to see that.
Actually,
so these are...
I was going to say, along those lines, and going back to the sort of Enable model of customizing something to fit an individual and, my interest as a teaching artist, I think, this open source clear mask with a vacuum former, if there are schools that have that Make You box available in their maker spaces, this is a fantastic way to kind of get into what is needed to customize an object to fit an individual person. So for students who are just kind of curious about like, how do I make a thing, whether it's, something like a clear mask or, a piece of armor for a costume, it's a really cool way to kind of see how things are made.
Oh, it is. And there's so much that we won't have time to get into it. But as John mentioned, I mean, this is 155 plus meetings, usually an hour or more each, all of which were recorded. Every meeting had notes which were stored. We have so much information that came out of this process, including, analysis of facial geometries, statistical averaging. I mean, just amazing, data. Testing results of our filtration materials, testing of the seal testing of how well our different designs fit on a face. We actually had those tested in the lab at the university environment, where they did sort of smell tests to see if you could, they'd have a strong scent that they would put to see if you could smell that through the filter. Just lots of great data and insights that came along the way of this process, all of which is, it's there, we have it. We're not going to, put all of that on the website, but we have it all and would be happy to share any of it that's of interest. So I think a lot came out of this that could be sort of the basis of further innovation and further collaboration, whether it's masks or something entirely different. Just the idea of, again, coming together across distances as volunteers to collaboratively design and then figure out how to scale up something to meet a need. It's a very powerful sort of combination of factors, and it was great to be a part of. So we are about out of time here. So I wanted just to ask if anybody has any final thoughts that you'd like to share before we wrap up here.
I don't want to open a new topic, Jeremy. It's too late for that. But I think that trying to figure out better ways to preserve what we've learned, making it readily available for the next crisis.
Yes.
And it seems clear to me that there will be another crisis, and that it will require possibly much better masks. Maybe we'll have fungal pandemics, and we'll have to have masks that can filter fungal spores. Who knows?
Right.
Is there any way that we can send this forward beyond what you're doing? And I think Enable is the best example I've seen. But
you're right, and
it still took a lot for us to get together.
I think the best vehicle we have for that right now is the website that Ben Rubin has put so much work into. But the reason I say it's a work in progress is because there's lots more of that sort of extracting the good bits from all of that documentation that we collected along the way. And we're going to continue doing that, going back through our notes, going back through the work that we've done in our recordings, and adding the useful bits into that website. So we'll continue to try to share that. Hopefully people out there in the community are going to take our designs and come up with further innovations and share those and share the result of their work. But you're right, that's often the challenge. It's
the people side of it that I'm thinking we aren't. The web's great, and the whole Enable process, but the local community coming together like that took time. And the next time we won't have so much time, maybe, who knows?
Well, I think you're right. I mean, part of it is just I think part of it is going to be helped just by the fact that we went through this, right? I mean, more people are aware of 3D printing and how that can help in a crisis like this. And if something like this were to come along, I think you would see that mobilization of the maker community probably more quickly, just because of having gone through it this last time. But you're right, it's a big challenge of how do you make that easier and more efficient, so that there isn't so much of a delay in getting that activated. Yeah.
One of the things I think Jim is sort of also pointing at, which was interesting in the process, is there's a level of patience to do these iterations and not go mad. And I think it's interesting. I mean, the human factors of it, trying to figure out, get everybody on the same page, but also encourage people to explore different things. I mean, I think it's worth remembering we ended up with 4 different designs, and they all covered different production. They all appeal to sort of different communities. They were all part of this process. And these 4 masks we ended up with were basically things that we circled around enough times to have enough documentation interest, but there was all these other masks that were sort of side projects that went in different directions.
Right.
But those iterations, how many times can you loop around something and not lose patience?
Right.
it's a challenge. And, again, like Jeremy, you said, we have hundreds of pages of notes. How can we use that to help not just repeat some of the things? And we did some of that, searching through, somebody mentioned this, let's pull this into the conversation. But those tools, I think, can be improved and help collaboration.
Yeah.
The other piece of that is also not just, we have this community now. It's another connection between, excuse me, different parts of the maker community, different, the more connections we have, the more resilient we are, whether that's with makers or with your neighbors. So I think maintaining that so that in the downtime when there isn't a calamity, how much better does a community respond to a calamity when you know each other? So you're not just like, hi, I'm your neighbor, your house is on fire. It's like, John, you need to get out. There's a connection there. There's trust there. There's an understanding of how this person needs to be communicated with. So I think that needs to be focused on or kind of kept going in the downtime. I think one of the other things that, myself, I would love to see, it's wonderful when you've got folks who have, the privilege of time and access and support from outside bodies. But myself as an independent artist who saw their income go basically in the toilet over the last year, from a maybe as a way for the government to kind of support the development of these sorts of endeavors, this resiliency, making it possible for people who are innovating to get some sort of living stipend. Because think of all of the learning and the techniques that we weren't able to access because someone that may be more skilled in sewing or more traditional handcrafts didn't either have access to the community or didn't have time to
You're
connect.
absolutely right. And it's, as you mentioned that, it's interesting because they have something like that for businesses. They have the research and experimentation tax credit, but why not for individuals? They're the ones that really made a difference this time. So that's an interesting point. And of course, making that easy to get access to is part of the challenge. It doesn't do anyone good if you have to spend 6 months filling out forms. So it would be nice to see that. It would be a great way to help further this kind of innovation next time around. So as I said, there's just so much to talk about when you've been through as much as we have. We won't get to all of it today, but I hope we can keep this conversation going through our websites and social media, and I hope people will reach out to us with any questions. I want to repeat the websites where you can find more information. The main one is bemask.org. That's the site where you can get all the details about this project and the different designs and testing and instructions and download files and everything else that you might want to know about what we talked about today. If you just want to get your hands on one of these clear masks that we showed you today and would like to see one for yourself, you can get one from beclearmask.org, beclearmask.org. That'll take you right to a page where you can get one or more of those masks all packaged up and ready to use. So if you want to check one out for yourself, you can head over to beclearmask.org. But please do check back to the bemask.org site from time to time, because we will be constantly adding to that, getting the latest files out there, the latest instructions, which are still being worked on. And it's a place also where you can reach out to us. There's a contact form there if you want to get engaged or ask questions. So head on over there to learn more. I want to thank everyone who joined in today. Really, it's been a pleasure talking with you and having you to work with on this project. Thanks all of you for your time. And thanks everyone for watching. As always, head on over to 3duniverseuntethered.com for a full list of upcoming episodes and to get the recordings of our previous episodes. You can also find us on all the major podcast platforms. So we'll see you in 2 weeks for our next one. Thanks everyone. Bye-bye.
Thank you.
Bye, everybody.